Okay, in this video, I want to talk about how we solve what we call linear equations. And so we're going to be using the rules that we have for simplifying algebraic expressions, like how you can combine like terms together and how we use the distributive property and stuff like that. But we're going to have one added element to this, and it's going to come into play whenever we go and try to solve for x in these equations, because that's really what we're doing. That's the main objective. So let's go into a few examples of this. So let's say that I have 8x minus 5 is equal to 3x plus 20. So the name of the game here is to get x by itself without any coefficients in front of it, and then arrive at an answer for x so that if we plug it back in, we end up with a true equation. So this is very similar to simplifying expressions using the operations we learned previously. And if you need to go over that, then the link to that video is going to show up right here. So if you haven't watched that video, please watch that one first, because you need those skills in order to solve linear equations. So it's basically the same thing as what we do to simplify expressions, except we have one added rule in there because the equal sign is here. So in order for this thing to stay equal to each other, if you decide to do something on one side of the equal sign, then you must do it on the other side of the equal sign. That's the only catch. So for this one, I'm going to take x and move it over to one side so that I have it combined together. So what I'm going to do is combine like terms, but the way I do that with an equal sign is by subtracting a 3x from both sides of the equation. So when I do that, on the right side I have 3x minus 3x, and the whole point of me doing that is to make that a 0, because 3x minus 3x is 0. And it simplifies the equation. But I also have to do it on this side. So I have 8x minus 3x, and that's going to give me a 5x. And then the minus 5 stays the same, and the 20 on the right side also stays the same. So notice how I have one less term on the right side by performing this. So the whole objective is to get x by itself. So what I can do is I can add 5 to both sides here, because I have a minus 5, and if I add 5 to that, I get a 0 again. And I have to add 5 to the other side too. So I am left with 5x is equal to 25. So now all I have to do to get x isolated is to divide both sides by 5. So 5 divided by 5 gives me 1, and then 1 times x is just x, so that's why I do that. And then what I'm left with is that x is equal to 5, because 25 divided by 5 gives me 5. And if I were to plug 5 back into this equation, let's say I have 8 times 5 minus 5 is equal to 3 times 5 plus 20. So the way that you check and see if your x value is right is plug it back into the original equation and see if it works out. So 8 times 5 is 40. 3 times 5 is 15. 40 minus 5 is 35. 15 plus 20 is also 35. So we have the same thing on either side, which tells us that this solution is correct. Okay, moving on. Let's say we have 7x plus 3 is equal to 3x minus 17. Okay, the first step I'm going to do is I'm going to get x on one side, because I see it's on both sides of the equal sign. So the way that I combine these like terms together is by isolating it. And I am going to subtract a 3x on both sides. 3x minus 3x is 0, and then I have 7x minus 3x, which is going to give me a 4x. And the plus 3 stays the same, and the minus 17 also stays the same. So we have one less term on the right-hand side, and all the x's are combined together. So I'm going to continue trying to get x by itself. So I'm going to subtract 3 from both sides. 3 minus 3 gives me 0. And negative 17 minus 3 gives me negative 20. So I have 4x is equal to negative 20. And then to get the x completely alone, I divide both sides by 4. 4 divided by 4 is just 1. 1 times x is x. So that was going to give me the x by itself. And then negative 20 divided by 4 is just negative 5. And so to check, I'm going to plug it in. So I have 7 times negative 5 plus 3 is equal to 3 times negative 5 minus 17. So 7 times negative 5 is negative 35, and 3 times negative 5 is negative 15. So negative 35 plus 3 is negative 32, and negative 15 minus 17 is also negative 32, so this solution is valid. Let's say I had 2 times x plus 5 is equal to, hang on. Let's say that I had 2 times x plus 5 minus 7 is equal to 3 times x minus 2. So what about this one? So if I want to get it into a form that I had before, all I would need to do is to distribute. So I distribute the 2 out to the x and the 5, and up with a 2x plus 10 minus 7, and then I distribute the 3 out. So I have 3 times x, 3x, 3 times negative 2 is negative 6. And I can combine the 10 and the negative 7 over here. So I have 2x plus 3 is equal to 3x minus 6, because 10 minus 7 just gives me that 3 down there. Okay, so now this looks a whole lot more familiar. So what I'm going to do is get all of the x's all on one side, and I'm going to do that by subtracting a 2x from over here. So it doesn't matter what side you start it from, but what does matter is that you have to do it on both sides for this to remain equal. So I've got 2x minus 2x, which is 0. The 3 stays the same. And then I have 3x minus 2x, which is just an x. And then the minus 6 stays the same. And so I want to get x by itself. So the way I do that is I'm going to be adding a 6 from both sides, because negative 6 plus 6 gives me 0. The whole point is to start creating zeros. So I'm adding 6 on both sides. So what I end up with is that 9 is equal to x. But it's always a good practice to check, so I'm going to plug it in. Plus 5 minus 7 is equal to 3 times 9 minus 2. So 9 plus 5 is 14. 2 times 14 is 28, so I'll have 28 minus 7. And 9 minus 2 is 7, and 7 times 3 is 21. And 28 minus 7 is in fact 21, so x is equal to 9. That's a valid answer for this. Okay, let's say that I had 3 times x plus 3 is equal to 5 times 1 minus x minus 1. Okay, so this is a lot like the last one. The first thing I'm going to do is I'm going to be distributing these out. So I have 3 times x, which gives me 3x, and then 3 times 3, which gives me a 9. And this is equal to 5 times 1, which is 5, 5 times minus x, which is a minus 5x, minus 1. And then I've got a 5 over here and a minus 1, so I can combine those to get negative 5x plus 4. Okay, so now we're in a much more familiar setting. So what I'm going to do is I'm going to get x all on one side. And I prefer to have negative coefficients in front of my x if I can help it. So I prefer to start over here, because if I add 5x to both sides, this goes away. And I end up with a positive 8x plus 9 is equal to 4. So I want to get the x alone. So the way that I do that is subtract 9 from both sides. 9 minus 9 gives me 0. The whole point is to make smart choices on what you want to cancel out to make the equation easier. So 4 minus 9 gives me a negative 5. So I'll have 8x is equal to negative 5. So bringing it up right here. And then the last step that I need to do is divide both sides by 8. So 8 over 8 is 1. 1 times x is x. So I have x is equal to negative 5 over 8. And just for fun, I'll check this one too. So I have 3 times negative 5 over 8 plus 3 is equal to 5 times 1 minus negative 5 over 8 minus 1. So 5 over 8 plus 3, or negative 5 over 8 plus 3 is 19 over 8. The 19 over 8 times 3 is 57 over 8. So I have a 57 over 8 here. And then 1 plus 5 over 8 is 13 over 8. 13 times 5 is 65 over 8. So I have 65 over 8 minus 1, which is just 8 over 8. So 65 minus 8 is in fact 57, so I have 57 over 8 is equal to 57 over 8. So this answer is valid. A little bit uglier on the check, but it still works even if you have fractions to work with. Okay, let's say that I had x over 5 minus 3 is equal to x over 3 plus 1. So don't get scared about the fractions. If you have a coefficient of 1 in front of your x on the top, or really any sort of coefficient, as long as you don't have x's on the bottom, you can treat this as a linear expression. So what I'm really saying here is x divided by 5, which is the same as 1/5 times x minus 3. And then this is 1/3 times x plus 1. So now all of a sudden it's just a linear equation with fraction coefficients. So it's going to work exactly the same way. So what I'm going to do is I'm going to subtract a 1/5 x from both sides, because 1/5 x minus 1/5 x is just 0. And whatever I do on one side, I have to do it on the other. So I end up with a minus 3 is equal to 1/3 minus 1/5 x plus 1. Now 1/3 minus 1/5 is 2 over 15. So I have negative 3 is equal to 2 over 15 times x plus 1. Okay, so now what I'm going to do is I'm going to get the x by itself by subtracting a 1 from both sides. So 1 minus 1 is 0, and negative 3 minus 1 is negative 4. So I end up with negative 4 is equal to 2 over 15 times x. So it does look a little bit funky when we have a fraction, but it's going to work exactly the same way. I'm going to divide both sides by 2 over 15. So I have negative 4 over 1 divided by 2 over 15. And this is why we learned about complex fractions, so that we can solve for x this way. And this is going to give me negative 60 over 2, which is just negative 30. So this tells me that negative 30 is equal to x. And if I plug in negative 30 in the original equation, I have negative 30 over 5 minus 3 is equal to negative 30 over 3 plus 1. Well, negative 30 over 5 is negative 6, and negative 30 over 3 is negative 10. Negative 6 minus 3 is negative 9, and negative 10 plus 1 is also negative 9. So I know that x is, in fact, equal to negative 30. So even if you have fractional coefficients, the process is still the exact same for solving linear equations. Get x by itself in any way that you can. And if you have a coefficient in front of x, just divide both sides by that coefficient. Last one that I do for today. So let's say that I have 4x minus 3 over 6 plus x over 4 is equal to x minus 2. So the first thing I'm going to do is kind of split up the fraction so that I have some definitive x and number terms together. So I can split up the big fraction on the left side as 4x over 6 minus 3 over 6 is equal to x minus 2. And so 4 over 6x is just 2/3 x. So I'll have 2/3 x plus 1/4 x minus 1/2, because 3 over 6 is just 1/2. And this is equal to x minus 2. So I can combine the 2/3 x and the 1/4 x together using the operations for fractions. And so this is going to give me 11/12 x when I combine those together. Minus 1/2 is equal to x minus 2. So even though we have fractions, we still have it in a form that is going to be familiar to us. So what I'm going to do is I'm going to subtract 11/12 x from both sides, because 11/12 x minus 11/12 x gives me 0. And so I'm left with negative 1/2 is equal to 1/12 x minus 2. And then what I'm going to do is I'm going to add 2 to both sides to get the x isolated. Oops, that's the wrong color there. So negative 1/2 plus 2 gives me a positive 3/2. And this is equal to 1/12 x. And so again, what I'm going to do is divide both sides by 1 over 12. So I've got 3 over 2 divided by 1 over 12. This is going to give me 36 over 2. Of course, the 1/12s cancel each other, so I'm just left with an x, which gives me an 18 is equal to x. And if I plug in 18 in the original equation, look what happens. So I got 4 times 18 minus 3 over 6 plus 18 over 4 is equal to 18 minus 2. So 4 times 18, that's 72. 72 minus 3 is 69. So I've got 69 over 6 is equal to 18 over 4, which is just 9 over, or plus 9 over 2 is equal to 16. So if I were to convert this into sixths here, I'd have 27 over 6. 69 plus 27 gives me 96, and then that is also equal to 16. So x is equal to 18 here is the answer. So I hope this video was helpful in determining how we can solve different types of linear equations. As you can see, we can do a lot of algebraic manipulation to get things that may not look like linear equations into forms of linear equations and then solve the regular process that we do to find x. So I hope this video was helpful. You found some value out of it. Stay tuned for